The topic is Bohr models hydrogen atom. To study this, we need to review what we learned before. We learned the electric force is 1/4 epsilon naught Q1 Q2 division by R square. And Newton's second law is mass times acceleration, which is a force. When you have a rotational motion, acceleration is v square over r. Kinetic energy is half mv square. Electric potential is 1/4 epsilon naught integration with respect to charge distribution and division by r. Electric potential energy is charge times potential. Angular momentum is r cross p. P is momentum. So if you put all together, we had 1 to 7 equations. Bohr postulated that angular momentum of electron in orbital motion is natural number times reduced Planck constant, n h bar. Here n is again natural number like 1, 2, 3, 4. But we know angular momentum is r cross p. The magnitude will be rp, sine angle between r and p. In this case, electron velocity vector is tangential direction. Radial direction makes right angle with respect to velocity direction. So angle is 90 degrees. Sine 90 is 1, so it becomes rp. P is momentum, which is mass times velocity, r and v. So from this you can write expression for the speed of electron in orbital motion and h bar of rm. Electric force is 1/4 epsilon naught. Two charge. One is electron itself. The other charge is the charge sitting in nucleus, depending on which atom. So we have a Ge is the charge amount in nucleus, and division by r square. Newton says force is mass times acceleration, and electron is making rotational motion, so acceleration v square over r. But we have expression for v, which is n h bar over rm. Plug that in, it turns out to be n square over n square h bar square division by r cube and m. For the case of hydrogen, z is 1, so we can write the expression for radius to be 4 pi epsilon naught n square h bar square division by e square and m. Now here n is variable depending on electron location. All the rest is constant. So we call this all the rest constant altogether a naught, which means Bohr radius. This Bohr radius you can calculate by plugging in those constant values. 1/4 pi epsilon naught is 9 times 10 to the power 9 Newton meter square per Coulomb square. H bar reduced Planck constant is 1.055 times 10 to the power negative 30 per joule second. Unit charge is 1.602 times 10 to the power negative 19 Coulomb. Mass of electron is 9.109 times 10 to the power negative 30 kilogram. Plugging all these values into expression, we have a Bohr radius approximately 0.0529 nanometer. What this means is r is a not n square. N is constant. N is a natural number, which means it cannot be any decimal value. That means an electron can have only certain allowed orbit, which means between two orbital paths there is no electron, which means just empty space. Speed expression, we have n h bar over rm. Now we have r expression, which is a naught n square. Plug that in, then we get simplified into h bar division by n m a naught. If you think about the innermost orbital pathway, which is orbital principal orbital quantum number is 1, n is 1, turns out to be h bar over m a naught. If you put the numbers in and evaluate it, and it turns out to be 2.2 times 10 to the power 6 meter per second. This value is even less than 1% of the speed of light in vacuum. C value is 3 times 10 to the power 8 meter per second. Total energy calculation is summation of kinetic energy and potential energy. Kinetic is half mv squared. From the first equation, which is 1 over 4 pi epsilon naught z e square of r square equals m v square of r. V square of r is acceleration a. From this, we can find the expression for mv square. That is to be z e square 4 pi epsilon naught r. Potential energy is negative integration from r to infinity. R is the radius, orbital has a radius from the nucleus. G square over 4 pi epsilon naught r square and dr. If you do this integration, it is negative ze square over 4 pi epsilon naught r. So we plug this expression and mv square into total energy expression, then we have this expression. So that turns out to be negative half 1 over 4 pi epsilon naught z e square of r. But we have r expression, which is 4 pi epsilon naught h bar square n square division by z e square and m. We plug that in, and energy turns out to be negative half me power 4 z square 4 pi epsilon r square h bar square n square. We plug all the constant values in. What's left as a variable is z and n, and this constant value turns out to be negative 21.8 times 10 to the power negative 19 joule. This joule is very large unit, so we want to use a smaller unit, which is an electron volt. 1 electron volt is 1.602 times 10 to the power negative 19 joule. Using that, we have energy expression negative 13.6 electron volt times g square over n square. Here g is atomic number, which is the number of proton inside the nucleus. So each atom will have different value. Again, n is a natural number, like 1, 2, 3, 4, 5, 6, like that, which cannot be any decimal value like 0.2 or 1.7 or 2 point any number. Okay? It cannot be like that. It has to be natural number. For the case of hydrogen, G equals 1. This G is 1. So the energy of electron in orbital motion for hydrogen atom is negative 13.6 division by n square. Unit is electron volt. So this n is natural number, which is principal orbital quantum number. Innermost one is 1, next one is 2, next is 3, and 4, 5, like that. Then what does this mean? Energy equation. Negative 13.6 is constant. G, depending on atom, n is a quantum number. For the hydrogen, G is 1, so it turns out to be negative 13.6 n squared. That means as n is a natural number, which cannot be any decimal value, so this energy of electron in orbital motion is quantized, which means only certain values of energies are permitted for electron orbiting around the nucleus. If n is large, which means electron orbital pathway is far away from the nucleus, then eventually that electron can escape from the atomic structure, which means it can be ionized. From the experiment, people came to know that the ionization energy of a hydrogen atom is 13.6 electron volt. Now, if we summarize what we learned now is speed of electron in orbital motion is n h bar division by rm. N is a principal orbital quantum number. H bar is reduced Planck constant. R is radius. M is mass of electron. Radius is Bohr radius, which is constant, times n square. N is again principal orbital quantum number. Energy of electron in orbital motion is negative 13.6 electron volt times z square over n square. Okay, z is a number of proton in nucleus, n is again principal orbital quantum number. Bohr's model is very good, but there's limitations because Bohr's model could not explain the bonding of atoms into molecules, like covalent bonding or ionic bonding. However, Bohr's model is very important as the beginning of quantum mechanics. Thank you. It's been Bohr's model of a hydrogen atom.